Set them equal. Quit because of y'all? I think not. Negative 2a equals 16, so a is negative 8. Y'all think you're the worst I have ever encountered? No. I've been teaching a long time.
You should quit because of Miss Finn. I ran the Rolex.
14. 1/4 to the 2x. 32 to the 4x minus 2. What's my base? 2. Negative 2 on this one. 5 on this one. I get negative 4x equals, I'm going to go ahead and distribute 20x minus 10. Subtract 20x and divide by negative 24. At least what I show.
Underscore, right?
No, you're not.
Underscore?
Dot. And then 18. 36. What is your 6? Thank you, Davis, who's actually paying attention and doing what they're supposed to do. You said you didn't know there was a back. Oh my gosh. To the what? Third. N. 6 to the third. 2n plus 1. I got 2n minus 3 plus, remember those add, 3n equals 3 times 2n plus 1. 2n minus 6 plus 3n equals 6n plus 3. 5n minus 6 equals 6n plus 3. Subtract, I get negative 9 equals n. Way that we write exponents, and if you can remember that logs are exponents, it will help you greatly. Today we're just going to be practicing changing from one form to the other, and that is going to be about, well, you might have a couple little evaluate, but nothing hard. So let me show you what it means. We've been working with exponentials, right? And we might have something like 3 to the x equals, let's say it equals 15. How in the world would you solve that? Because there's no way for me to write 15 with a base of 3, right? And that's what we've been doing. We've been manipulating the bases so that we can set the exponents equal. But what happens whenever I can't? Well, we have logs for that. So I'm going to call this, I'm not going to call it, it's just what it's called, exponential form. And I can change into what we call logarithmic form by doing this. I do the log, and now this is written really little as a subscript, so be careful. The base is 3 of 15 equals x. Okay, that's changing the form, so this is logarithmic form. So in general, if you have, and you have to, whenever, you'll be good with logs when you can move fluidly between the two forms. And it's not hard, it's just remembering what goes with what. Log base b of a equals x. So in exponential form, what would that look like? B, close, b to the x equals a. I always tell my students when it's written where log comes first in the equation, and you're trying to get it in exponential form, you can make an e, b to the x equals a. You see my e that comes out there, so I'm in silly little e thing to help you remember how to change it into the forms. But remember, logs are exponents. That's why logs equal the exponent all the time. Okay? You don't get what? Okay, so let's say I have Log base 3 of 9 equals 2. Write that in exponential form. Try it. use the little guide that I gave you here. This is exponential and logarithmic forms. They're the same thing. So write it in exponential form. What's the base? 3. Logs are exponents, so what's the exponent? 2. What's it equal? Is that true? Yes. We're not solving anything yet. We're just rewriting. We're changing forms right now. I haven't shown you how to do that. I was just showing you how to change forms. It doesn't matter. Yeah. How about this one? Change the form. Sure it does. What's the base? What's the exponent? Equals. No, that is the solution. No. What do you mean switch B and X? Log base B of A equals X. How about this one? What's the base? 9. What's the exponent? Equals. Is that true? Exponent of 3/2 means square root cubed. Square root of 9 is 3 to the third power is 27. It is true. Remember what this means. This means the second root of 9 to the third power. Square root of 9 is 3. 3 to the third is 27. How about the other way? Write that in logarithmic form. What's the base? Okay. Logs always equal what? Exponents. So what's left? You're going to get yourself in trouble trying to remember it like that. But right now we're just swapping forms, but we're fixing to crank it up a little bit. Today's not hard. Change the form. What's the base? Of equals. When we start solving. Couple of things to note. Common base. If there's no base on your log, you know how there's always an imaginary everything in math, right? No exponent, it's a 1. No coefficient, it's a 1. No k, it's a 0. Here, if there's no base, it's a 10. That's because we operate on a base 10 number system, right? Okay. 0 through 9, and at 10, 1, then it starts over. So then you hold the place with a 1, and then it goes 0 to 9 in the next place. Okay. It's a base 10 number. You know how you do binary coding in computer science? Okay. What? I don't know. That I couldn't tell you. Log base 100 of 2. Is that what you're saying? Oh, log 100. Yes. Yes. Tell me what it equals. What you got, Corey? 1? Nope. Why? What would I need to put here to make this equal 27? 3. But I do have a base here. What's that equal? Why? What power would you need to raise 7 to get 49? What's that equal? What? 2, 4, 8, 16, 32, 64. Solomon, that one's for you. 2 to the what power gives you 64? 6. So now this one is 10 to the what power gives you 1,000? Because the base is 10, because it's not here. What if I went backwards a little bit with it? Not backwards, but... Whoa! Look at you, Sonny! -2. I know I gotta flip it, right? That's the negative, and then 9. So 9 to the -2. See why we pounded those exponent properties and all those negative and... That's exactly right. Not -2. What did you do? Explain it, Sonny. You do an exponent of 1/2. That's exactly right. Not 1/4. 1/3. 1/3. That's exactly right. Because the third root of 64 is 4. The third root of 64 is 4. Yeah. Now, what happens if I don't want to teach you that yet? Because 64 to the 1/3, because it's Wednesday, they're later. So the cubed root of 64 is 4. I know, honey, you have not hesitated to tell me how long we have, but you've been wrong the whole time until just now. How about this one?
You got 9 minutes to do a quiz.
Oh, no break.
Uh-oh. How about this one? What's it equal?
7.
0. Right. Is it 7? 3 times 3 is 9, 27, 81. 6.
Oh, no, it's not.
It's 5, isn't
Bro,
it?
what
That's
does
what
this
it's
even
saying.
mean?
5.
Nobody understands.
Everybody understands. Sonny, you understand?
3 to the what power gives you 243? Try 3 to the 5th.
No, it actually might say
Put it in your calculator.
Which one was 64? What do you have to raise 64 to get 4? So here's the way I think. Listen, this will help you. If you're going from a whole number to a smaller number, right? I'm thinking that I got to take a root, so I'm thinking about a fraction for an exponent. If you're going from a whole number to a fraction or vice versa, I'm thinking about a negative exponent because that's what flips it over. Yeah. Yes. No. Which one? This one? 3. Yes. Yes. How about
Are you going to be able to do final or it doesn't matter?
I am.
You're not making.
So, what does the log even stand for?
Way to rewrite it with exponents.
What does it stand for?
What's this equal? It's -2. Why is it -2?
Yeah, why is it negative?
I gotta flip it, right? Flipping it, knowing that I have to flip it tells me the negative. And then 4 to the what power is 16? I don't know. All right, let me give you one more. I'm almost done. Stay with me.
I never pitch.
Take out your calculator. I want you to look at your calculator real quick, and I want you to notice. I want you to notice something on your calculator. On your calculator, if you push log, most of you under the x squared right beside the 7. Most of you, when you push log though, you can't change the base. Okay, some of you can, but most of you can't change the base. So it's just log, and if there's no base indicated, what's my base? 10. So whenever I hit log, it's automatically assuming a base 10, so I can't type this in. So we use what we call a change of base. And you're going to need to know this formula even if your calculator does it. Change of base says you would take log of 54 divided by log of 2. And now this base could be anything you wanted it to be. It could be 10. It could be 1,000. It doesn't matter. As long as it's the same on the top and the bottom. So we can use our calculator to say, well, what is log 54 divided by log 2? You shouldn't get a log.
5.75488750.
Yes.
Yeah, that.
Okay. So in fact, all of the ones that we've done, you could use the calculator to evaluate. Okay. If I go back here, let's say this one. How would you put that in the calculator?
To the 4th times 160.
You don't understand what? Okay, so if this was what I was asked, right, and I wanted to change a base, I could take out my calculator and could do log of 1 over 16 divided by log of 4. And you should get -2, but put it on your calculator and see.
You don't need to know this.
Yeah, you do. What? Yes,
Put
you
it in
can.
your calculator.
I'm telling you, you could make that base anything in the world, and as long as you do this one on top and this one on the bottom, and these are the same, I could have a base of, I don't know, Adriana, 54, divided by log base Adriana of 2. Anyway, you see what? But what I'm saying is it doesn't matter. Okay. It doesn't matter. It doesn't matter what the base is as long as it's the same. All right. I know that was a quick